Hi and good morning everyone. I believe all of you have copied these notes of topic 1.4 about measuring instruments. So here we have a subtopic of use of right measuring instruments, which are, for example, the first one to measure length, and we need ruler or measuring tape for us to measure length. Either it is in centimeter, millimeter or kilometer. And the second one, to measure mass, we need level balance and triple beam balance here. And at all times they use a weighing scale. And then the third one is to measure time. We need a stopwatch, where you can find this in the lab. And number 4, to measure temperature, you need the laboratory thermometer or clinical thermometer, where you can find in hospitals or clinics. And then to measure the electric current, we need an ammeter. Alright, this is an ammeter. And of course we need to calibrate, right, the zero error and the random error. Next one, to measure the volume of water, we need measuring cylinder. And please be careful that to prevent parallax error. Okay, so it's always occur when the reader's eyes are not perpendicular to the reading scale. So make sure your eye level is at this point. Right. For tutorial today, you are going to learn a little bit about using measuring instruments with higher accuracy. Okay. The first one is to measure the length using Vernier calipers. Okay, this is Vernier calipers. As you can see here, there is a round object here, for example a bottle. So Vernier calipers is used to measure the thickness, okay, the thickness or outer diameter, inner diameter and depth of an object. So the smallest division of the reading of Vernier calipers is this one is 0.01 centimeter or 0.1 millimeter. So therefore, Vernier calipers is much more accurate compared to a ruler, which can only measure the smallest reading up to 0.1 centimeter or 1 millimeter. So what you need to know is the most important part is to read the Vernier caliper. Okay, the first step here, look at this part. Alright, so this is the main scale and this one is the Vernier scale. First one, you need to read the main scale first. Okay, can you see the red arrow here? Okay, first step, all you need to do is to read the line before the point 0 here. Okay, the line before means for this one 3.2. okay, this one is 3.2. Second step, you need to read the Vernier scale, which is 0.02. so I hope you notice that the Vernier scale here coincides with the main scale at 0.02 centimeter. Okay, next, the third step, you need to add 3.2 plus 0.02 and then you will get 3.22 centimeter. Okay, alright. So next one. Okay, next one is to measure micrometer screw gauge. Okay, this one is the micrometer. So a micrometer screw gauge is used to measure the thickness and diameter of small objects like paper and hair, okay, even a piece of paper and also hair. The smallest division of the micrometer screw gauge reading is 0.001 centimeter or 0.01 millimeter. Here you can see here, okay, this one is 0.01 millimeter. So therefore the micrometer screw gauge is more accurate than the vernier calipers just now. Okay, look here, we are going to learn how to read the micrometer. Okay, the vernier scale has 50 divisions. Okay, 50. Okay, from this picture you can see only 45, but actually it has 50 divisions. So each division on the vernier scale, this one is the vernier scale, is 0.01 millimeter. Okay, the small part here is 0.01 millimeter. Okay, so let's read together the micrometer screw gauge. Okay, first step, you need to know this is the main scale, this one is the vernier scale. Okay, read the main scale first. Okay, this one, as you can see, is 3.5 millimeter, not centimeter. The second step, read the vernier scale. Okay, at this line, okay, this one is 38. Okay, let's see, 35, 36, 37, 38. So 38 means 0.38 millimeter. Okay, so the third step, you need to add together 3.5 and 0.38 equals to 3.88 millimeter. Alright, so the right way to take a reading to avoid parallax error is like this. Okay, so this one is how you can read the zero error. Okay, the zero error of the micrometer screw gauge can be determined when the anvil is closed completely. Okay, where is the anvil? This one, anvil. Okay, when the anvil is closed completely means you need to store this micrometer back to the lab. Okay, you need to make sure the anvil is closed completely, and then you can make sure that there is no zero error. Okay, if the reading is at this point, so meaning you have no problem at all because no zero error. But okay, if the reading is like this, the second picture or the third picture means you need to plus either the positive zero error or to subtract the zero error. Okay, so what I'm going to do is to use this formula. Okay, the formula is actual reading equals the reading of micrometer screw gauge, this one just now. This is the reading, and I need to subtract zero error if it has zero error. Okay, so it will be positive zero error if the reading is like this, means zero is at the below part. Okay, but it is negative zero error if zero is at the upper part. Okay, at this part. Okay, so that's all for today. Alright, bye bye.